Good morning, all. First of all the best for all students for the upcoming uh, mathematics examination. Today, we will discuss some important questions related to linear programming problems. So, our topic of discussion is LPP, linear programming problems. So, here, what are the basic concepts you required is here you can see one graph. This is our x-axis, this is y-axis. We should know that what is the equation of x-axis. X-axis means the equation. X-axis is also a line, therefore the equation is y equal to 0. Y-axis is also a line, therefore x is equal to 0. So if somebody represents a region x greater than or equal to 0, you have to consider this area. This is x greater than 0 because x is equal to 0 is y-axis. If somebody is saying x less than 0, x less than 0, then we should consider the other area. This basic knowledge we required. Another thing, similarly, again, this is x-axis, y-axis, and equation of x-axis is y equal to 0, and equation of y-axis is x is equal to 0. If someone is saying y greater than or equal to 0, then you have to consider this area. If someone is saying y less than or equal to 0, you have to consider this area. This is the basic knowledge you should require. Now we will discuss one question. The question is, we have an objective function. Z is equal to 9x plus 13y. This is our objective function. Objective functions means this is our target. Whether we need to maximize the objective function or minimize the objective function. For example, in a factory, if we want to if we want to get the profit, our aim is to maximize the profit. In case of labor charge, our aim is to minimize the labor charge. So by looking into the task, we will be able to finalize whether it is we need to maximize or minimize. So such that is known as objective function. Here in this problem, objective function is given as z is equal to 9x plus 13y. Now we will have so many constraints. So we will write constraints here. Constraints. Constraints 1 is 2x plus 3y less than or equal to 18. Another one, 2x plus y less than or equal to 10. Another constraint, x is greater than 0, y is greater than or equal to 0. These are the constraints. So we have 4 constraints. Number 1, 2, 3, 4. Now you have to solve this problem by graphical method. Graphically, we have to solve this problem. So how to solve? For that purpose, now we will draw our graph. First of all, we will make a tabular column like this. Here we will write our equation, constraint, then we will put x, y, then you will get the combination of x comma y, then we will consider the sign provided, then we will represent the region. First we will write 2x plus 3y. 2x plus 3y. Here our equation is 2x plus 3y less than or equal to 18. So our sign is less than or equal to 18. So less than or equal to our sign. So we will put 2x plus 3y equal to 18. So now we will solve. 2x plus 3y equal to 18 means 2x plus 3y equal to 18. First you have to put x is equal to 0. If you put x is equal to 0, in this equation 2 into 0 plus 3y equal to 18. So you will be getting 3y equal to 18 implies 8y equal to 18 by 3, 6. So here you are getting a coordinate x comma y is equal to 0 comma 6. So here we assumed x as 0. We are getting y as 6. So our coordinate is 0 comma 6. Now in first case we put x is equal to 0. In second case you have to put y equal to 0. Y equal to 0 in the same equation. So 2 into x plus 3 into 0 equal to 18 implies x is equal to 18 by 2. So you'll be getting 9. So here our x comma y is 0, 9 comma 0 because x is 9 and y is 0. So you can consider. So here we put y equal to 0. We put y equal to 0 and you are getting x is equal to 9. So our coordinate is 9 comma 0. So what is the region? How to find out the region? So for that purpose we have to draw the graph. Now we will put graph here. This is x-axis and this is y-axis. So we require to show 2 points 0 comma 6 and 9 comma 0. 9 comma 0. So this is our origin. This is our origin. So this is our point 1, 2, 3, 4, 5, 6, 7, 8, 9. This is our point 9. Or you can say that it is 9 comma 0. Similarly, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5. This is our point of interest, not that point 6. So 1, 2, 3, 4, 5, 6. This is our point of interest. So this can be put it as 0 comma 6. So our point coordinates are 0 comma 6 and 9 comma 0. So just connect these 2 points. So you can write like this. We can draw. This is our line. What is this line? The equation of this line is, you can write 2x plus 3y equal to 18. The equation of this line is 2x plus 3y equal to 18. This is the equation. Now you have to consider the sign. What is the sign? 2x plus 3y is less than or equal to 18. That is our sign. 2x plus 3y less than or equal to 18. So here you can able to see, this is our origin. The region, here there are 3 regions. One of the region is only above the line, not on the right side or left side of the line, but it is purely on the line. Another region, second region is the right of the line, and another region is the left of the line. So there are 3 regions can be represented by a straight line. So the region which contain the origin, we can call it as origin side. The region which do not contain the origin, That means 0 comma 0 is if the considered region consists of the point 0 comma 0, that means origin, you can say that it is origin side. So other side is non-origin side or not origin side. Okay, so now I will consider a point on the origin side. So for example, suppose my equation is 2x plus 2x plus 3y 2x plus 3y less than or equal to 18. So this is my, so if you take any point from here, that is origin is 0 comma 0, and if you put in this equation, when you put x comma y equal to 0 comma 0 on the left side of this equation, that means 2x plus 3y. So you will be getting 2 into 0 plus 3 into 0. So 0 plus 0, it is 0. It is clear that 0 is less than or equal to 18. So this is our LHS part and this is our right hand side part. So by putting the coordinate 0 comma 0, we understood that the considered point satisfy the equation, that is 2x plus 3y less than or equal to 18, matlab 0 is less than or equal to 18, that is a true statement. Then we can say that the point we considered is the required area of interest. So here you can do like this. So here the area of interest is like this. This is our area of interest. So since the output we got is the origin side, we can put here, we can represent origin side of line. Here we can write origin side. If this line is L1, then origin side of L1, that is the solution we got for the 2x plus 3y less than or equal to 18. So when we are drawing 2x plus 3y less than or equal to 18, you are getting the origin side. Similarly, next equation, 2x plus y less than or equal to 10. 2x plus 3y, 2x plus y less than or equal to 10. So we will extend this. Our equation is here also sign is less than or equal to. So 2x plus y, instead of greater than or equal to or less than or equal to, we will put equality only, 2x plus y equal to 10. So here the same thing we will do here also. Our equation is 2x plus y equal to 10. 2x plus y equal to 10. We will do first case, second case. What is first case? We will put x is equal to 0. So you are getting 2 into 0 plus y equal to 10. So 0 plus y equal to 10. 0 plus y equal to 10. So what is the meaning? Y equal to 10. So you are getting a coordinate x comma y equal to 0 comma 10. So when you are putting x is equal to 0, you are getting y equal to 10. So when you are putting x equal to 0, you are getting y equal to 10. Y equal to 10. Therefore, our coordinate is 0 comma 10. 0 comma 10. Next, we will put y equal to 0. Y equal to 0. So when you are putting y equal to 0, you can write 2 into x plus 0 equal to 10. Meaning is 2x is equal to 10 and x is equal to 10 by 2 and you are getting 5. So x comma y is equal to 5 comma 0. You can choose any point. It is not compulsory that we should use x is equal to 0 in the first case and y equal to 0 in the second case. In order to minimize our effort for calculation, we are using x is equal to 0 and y equal to 0. When you are putting x is equal to 0, you'll be getting some point that can be considered as one of the coordinate. When you are putting y equal to 0, you will be getting another x comma y coordinate that can be considered as another coordinate. By using these two coordinates, you can extend a line. You can choose any point, no issue. But for our calculation simplicity, we are using x is equal to 0 and y equal to 0. So here we got the point is 5 comma 0. So here we are putting y equal to 0, y equal to 0, and we are getting x is equal to 5. So our point of interest is 5 comma 0. 5 comma 0. So we are getting 0 comma 10 and 5 comma 0. 0 comma 10 and 5 comma 0. So 0 comma 10. So that means y. So we can put, so this is 7, 8, 9, 10. So this can be considered like this. So here you can little bit extend. So this is our y-axis, and this is our point 6, 7, 8, 9, 10. This is point of interest, and it can be represented as 0 comma 10. 0 comma 10. The other point is 5 comma 0. Here 1, 2, 3, 4, 5. So this can be considered as 5 comma 0. By using 0 comma 10 and 5 comma 0, you can extend a line here. So this is our line 2. This is our line. So this line can be represented as 2x plus y equal to 10. So this line, equation of this line is 2x plus y equal to 10. 2x plus y equal to 10. So that is the equation of that line. So here also we have to consider whether our required area is lying on the origin side or non-origin side. So what we have to do, we can take any point on the right or left of the received line. So for example, here also I am putting origin. By using origin, I am going to check. So my equation is 2x plus y less than or equal to 10. So this is my equation, 2x plus y less than or equal to 10. Suppose I am putting x comma y equal to 0 comma 0. So what I will get? So here also, this is our LHS part and this is our RHS part. Put that x comma y0 in the LHS part and check whether what is the value you are getting and whether that point satisfy the given inequality. So you will be able to write 2 into 0 plus y equal to 0. So y equal to 0. So you are getting answer 0. That is also equal to less than 10. So here also 0 is less than or equal to 10. That meaning is our inequality is satisfied. So when you are taking a point from the origin side, and if it is satisfied, then our region of interest is origin side. If that is not satisfied, we will consider the opposite side. If right side is not satisfied, then automatically we know that the region of interest will be left side. So here we are getting on the in both cases we are getting on the origin side. So we will be putting it as origin side. So our area of interest is here we will represent So our area of interest is origin side. So this is our area of interest. So here you can write the second line is L2. Second line is L2. L2. Therefore, and we are getting on the origin side. So we will be writing origin side of L2. So the solution for these two constraints, the solution for these two constraints is one is first is for origin side of L1 and the other is origin side of L2. Now we have another two equations. One is x is greater than or equal to 0 and y is greater than or equal to 0. So I already told you x is greater than or equal to 0 means area of interest is this one. This will be the area of interest. X is greater than 0. X is equal to 0 means equation of y-axis. Similarly, y is greater than or equal to 0 means our area, y equal to 0 means x-axis. So y greater than or equal to 0 means this will be our area of interest. So same thing we can apply here also. So when y equal to 0 means x-axis. X is equal to 0 means y-axis. So y greater than 0, the area of interest will be upward direction. Upward direction. X greater than 0 means our area of interest will be in this direction. So finally we are getting a common area by considering all the constraints. By considering all the constraints, you are getting this area in total. This is the area satisfied by the four constraints. By using all the four constraints, we are getting a common shaded area. Each line have its own shaded area. And there are four lines: x is equal to 0, y equal to 0, 2x plus 3y equal to 18, 2x plus y equal to 10. For all these four constraints, there are separate region of interest. But when you are combining four of them, we are getting a intersecting. Matlab, that is the meaning means the area which is common for all the constraints. So you are getting this area. So in a LPP problem, if you are getting such an area that is common area for all the constraints, then we can say that that area is known as feasible region. That area is known as feasible region. That this area is known as feasible region. So that is the meaning of feasible region. The area common for all the constraints. The region common for all the constraints. That the meaning is feasible region. So inside that feasible region, any one point, any one coordinate is satisfied by all the constraints. All are interested in that point, any point in the feasible region. Such a solution is known as feasible solution. For example, here, this is our area. This is our area. This yellow shaded portion is our area. Any point in this bounded, here all sides are covered by the lines. So we can say that it is a bounded solution. Bounded solution means all the sides are blocked, all the sides are covered by lines. So we can call it as bounded region. That is the meaning of bounded region. Bounded region. So feasible region, if you are getting a common area, we can call it as feasible region. Any one point in that area is known as feasible solution. And if the area is covered by all the sides, we can call it as bounded. There is very clear cut boundary is there for that area of interest, then we can call it as it is bounded region. If two sides are, or some portion is blocked by the lines, but the remaining portion is open to infinity, then we will call it as unbounded region. Unbounded region means, for example, if you are getting a solution like this, means we are getting a solution like this. So we know that this is boundary, this is also boundary. Here line is blocked, here also line is blocked. So here boundary is there, well defined boundary is there. But when you are going to this area, boundary is not there. So this is a unbounded region. Unbounded region. But in our question, all area is protected by or covered by our constraints, then it is a bounded region. So what is feasible region? What is feasible solution? Bounded region, unbounded region. Then what is optimal solution? Optimal solution. What is optimal solution? Optimal solution means, here you can see in our area there are so many points. So many points are there. So many points. All points are feasible solution. But optimal solution, where it will come? You have to consider the corner points of the boundary area. You have to consider the corner points. What are the corner points? Here you will be getting a corner point. Here you will be getting a corner point. Here also you will be getting a corner point. Here also you will be getting a corner point. So here there are 4 corner points. In the feasible region, there are 4 corner points. So optimal solution will be at corner points. Optimal solution will be at corner points. So what are the corner points here? Here we know that one corner point is 0, 0. That is pakka clear. One of the corner is origin. The other corner is 0, 6. The other corner is 5, 0. So we can write corner points here. Corner points. In our question, corner points. What are the corner points? First one, 0, 0. Second one you can see is 0, 6. 0, 6. 0, 6. If you want to give some names for that, here this is origin, this is A, and this is B, and this is C. So A is 0, 6. B we have to calculate. Here it is clear that B is a intersecting point of two lines. So by using the concept of linear equation in two variables, you have to calculate the intersecting point of these two lines. So you will be getting the corner point B. So how to calculate this? We will see. So third one is, so this is point O, this is point A, and this one we have to calculate, that is point B. How to calculate? We will see. First case is automatically here. We can, fourth point is actually C. Here it is clear that that point is actually 5, 0. 5, 0. Point C is 5, 0. So we can write that also. Then we will be able to solve that B also. Please look here. Our question, our lines are, first line is 2x plus 3y equal to 18, and the second line is 2x plus y equal to 10. So need to take only equality because we are solving linear equation in two variables. So by using eliminating method, you will be able to find out the value of x and y. Here already the coefficient of x is same. So simply you can do minus operation here. So 2x minus 2x. So here could put minus, here put minus, here put minus. Just add 0. 3y minus y means 2y. 18 plus minus 10 equal to 8. So you'll be getting y equal to 8 by 2, that is 4. You are getting y equal to 8 by 2, 4. So then you can select any of the equation. 2x plus y equal to 10 is our equation, one of the equation. So if you already we received y equal to 4, then just put 2x plus 4 equal to 10. Therefore 2x is equal to 10 minus 4 equal to 6. So x is equal to 6 by 2, 3. So you are getting x is equal to 3 and y equal to 4. So our coordinate is x comma y equal to 3 comma 4. So here 3 comma 4 is the point, 3 comma 4 is B. So here you can mark that point here. This is 3 comma 4. So we are getting 4 corner points. So first of all, if you are getting for all the constraints, for all the given constraints, if there is a common area, we can say that we have a solution. We have a solution. If for the all constraints there is no common area, there is no solution. No common area, no solution. Common area is there, we have a solution. We have a solution. So we will consider that common area as feasible region. So any point in that feasible region is known as feasible solution. So there are infinite number of points. In this yellow region also you can see there are infinite number of points. So infinite number of feasible solutions are there. What is optimal solution? What is optimal solution? That can be obtained in the corner points of the shaded area. In this particular example, there are 4 corner points. So in that particular points, you will be able to get the optimal solution. Optimal solution. Okay. So what is optimal solution? We have a objective function. We have a objective function. It may be sometime it may be maximize the objective function. Sometime it may be minimize the objective function. Now here our task is maximize. So optimal solution means it optimizes the objective function. It optimizes the objective function. So now we have to consider the objective function. What is our objective function? Objective function is z is equal to 9x plus 13y. Z is equal to 9x plus 13y. Here they given it as maximize. maximize z is equal to 9x plus 13y. So we will consider 9x plus 13y. So z is equal to 9x plus 13y. Now what we have to do? We have to take each corner points and put it in the objective function. So first point, that is point 0 comma 0, 0 comma 0. If you put in the z, so you will be getting z is equal to 9x plus 13y, so equal to 9 into 0 plus 13 into 0, you will be getting 0. 9 into 0 plus 13 into 0, so answer is 0. Second point, what is second point? Second point is 0 comma 6, 0 comma 6. You can put in the maximum objective function. So z is equal to 9 into 0 plus 13 into 6. So you'll be getting 13 into 6. 6 into 3, 18. Remainder 1, 6 into 1, 6 plus 1, 7, 78. So in second point, you are getting 78. Third point. Third point, we can consider 3 comma 4. 3 comma 4. So this point is O, this point is A, and this point is B. 3 comma 4. So Z is equal to 9x means 9 into 3 plus 13 into 4. 9 into 3, 27. 13 into 4, 4 into 3, 12. Remainder 1, 4 into 4, 4 into 1, 4 plus 1, 5. So you'll be getting answer 9, 7, 79. Then point number 4. What is point number 4? 5 comma 0. 5 comma 0. That is point C. 5 comma 0. So 5 comma 0. Substitute in this equation. 9x plus 13y. So 9 into 5 plus 13 into y. Y means 0. So you are getting answer 45. Anyway, you are getting 4 values. 0, 78, 79, 45. So here you have to consider the maximum value. Maximize function means you have to consider maximum value. Minimize the objective function means we have to consider the minimum value. Please listen properly. Maximize the objective function means out of this corner point, when you are putting the corner points in the objective function, you will be getting so many values. So maximize the objective function means you have to consider the maximum value among the corner points. If the task is minimize the objective function, we have to consider the minimum value. So here our task is maximize. So our maximum value is 0, 78, 79, 45. Out of these 4 values, maximum value is 79. So maximum is 79. So in order to maximize the objective function, we have to consider the value 3 comma 4. In order to maximize the objective function, we have to consider the value of xy as 3 comma 4. So our target is to maximize our objective function. So in order to get the maximum value for the objective function, which value for the parameter we have to choose? You can choose x is equal to 3 and y equal to 4. If you choose x is equal to 3 and y equal to 4, you will be able to maximize your objective function. If the question is minimize the objective function, what do you have to do? You can see minimum values at 0 comma 0, because out of 0, 78, 79, 45, the minimum value is 0. Minimum value is 0. So at what point? Here we are getting x comma y, you are getting 0 comma 0. 0, comma 0. So minimize means you have to consider the value of x is equal to 0 and y equal to 0. If the but our question is maximize the objective functions, so you have to consider x is equal to 3 and y equal to 4. So this is our solution of this question. So once again I will give you a brief. So our question is maximize the objective function z is equal to 9x plus 13y. So 9x plus 13y is our objective function. So what are the constraints? 4 constraints are given. First constraint is 2x plus 3y less than or equal to 18. Second constraint 2x plus y less than or equal to 10. Third constraint is x is greater than or equal to 0. Fourth constraint is y is greater than or equal to 0. So our aim is to solve this question graphically. So first of all, we have to draw a table like this. So here equation of the constraint can be written here. So 2x plus 3y less than or equal to 18, it is put like we are not considering the greater than or less than value, we are simply putting equal to 18, so that can be considered as line number 1. Similarly 2x plus y less than or equal to 10, we are not dealing with the, we are not considering the inequality, so we are putting 2x plus y equal to 10, that can be considered as line 2. So now you have to put any value of for x. For simplicity, I choose x is equal to 0. So in the first case, 2x plus 3y equal to 18. When you are putting x is equal to 0, y equal to 6. So you are getting a coordinate 0, 6. When you are putting y equal to 0, you are getting x is equal to 9. You are getting 9, 0 as the coordinate. So by connecting 0, 6 and 9, 0, you are getting some line like this. Like this, 2x plus 3y equal to 18. So in that particular line, there are three portions are there. One on the above the line, one is right side and the other is left side. So you have to consider any point on the right or the left of the line, then put it in the equation, inequality equation of that particular line. If you are getting satisfying, then the region from which you took the point can be considered as the required region of interest. So here, if you are getting a point from the origin part, then a region of interest is origin side. If you are not getting from the origin side, if the some other point which is not in the origin side is satisfying, then our region of interest we can consider as non-origin side. By using the same technique, we are using calculating the equation of 2x plus y less than or equal to 10 also. So when you are putting x is equal to 0, you are getting y equal to 10, and when you are putting y equal to 0, you are getting x is equal to 5. By connecting 0, 10 and 5, 0, you are getting uh, uh, a straight line. Then same thing can be applied here also. You can take any point on the origin or non-origin side and substitute in the inequality equation. When it is satisfied, the corresponding area can be considered as region of interest. So based on our calculation, we got both on the origin side. For 2x plus 3y equal to 18 also origin side, and 2x plus y equal to 10 also origin side. Then another two equations given is x is equal to 0 and y equal to 0. X is equal to 0 means that is y axis. So x is greater than or equal to 0 means that will be the right side of the y axis. Similarly, equation of x axis is y equal to 0. If y greater than 0, the meaning is the region of interest is above the x axis. So by considering the condition of all the constraints, all the four constraints, you are getting a common shaded area, which is satisfied by the all four constraints. So if in an equation, when you are doing some problem like this, if you are getting a common area, then we can call it as, we can say that there are some solution for this particular linear programming problem. If you are not getting any common shaded area, then there is no solution. There is no solution exist for this particular linear programming problem. Then another thing, the shaded area we got received is, we can call it as feasible region, and any point in that feasible region, we can call it as a solution of this linear programming problem. So that can be considered as feasible solution. Then we have some target to optimize the objective function. That is our target. It may be we have to maximize the objective function, or sometimes we have to minimize the objective function. Anyway, our target is to optimize the objective function. So in that complete area, we are getting so many solutions. There are infinite number of solutions, but which solution is best? Which solution is best? That the we can call it as optimal solution. So optimal solution normally we will be getting in the corner points of the area. So here our feasible region is bounded by all the sides, bounded by lines in all sides. So we can say that this area is completely bounded. So we can say that it is a bounded region. Sometimes uh, some portion may be covered by our constraints or our line, but some portion may be open to infinity. In such cases, we can say that it is not bounded. Instead of that, we can call it as unbounded. So anyway, in our question, we got bounded uh, a region, and we are getting 4 corner points. First point is origin 0, 0. Second point is 0, 6, and third point B, that we have to calculate because we have two equations, two straight line. By using the concept of linear equation, two variable, the intersecting point of the line can be calculated. So we are getting 3, 4. So 0, 0, one of the corner point, 0, 6, another corner point, 3, 4, another corner point, and 5, 0 is the fourth corner point. So we are getting 4 corner points. So optimal solution will be at any of these corner points, at any of these corner points. Now, we can put this equation in our objective function. Our objective function is 9x plus 13y. So by putting the corner points in our equation, you are getting, in objective function, we are getting 4 different values: 0, 78, 79, 45. So if our aim is to maximize the objective function, you can say that you have to take the maximum value among the corner points. Meaning, when you are putting that corner points in the objective function, which case we are getting maximum value, that we consider as the maximum value of the objective functions, that corresponding value of x and y can be taken as your optimal solution. If the question is minimize the objective function, out of these 4 cases, which corner point have the minimum value, that corresponding coordinate can be considered as the optimal solution. If the case is minimize the objective function. If the maximize the objective function, you have to consider the maximum value at the corner points. So this is the case. So sometimes you may get infinite number of solutions. Here we are getting only unique solution. When we are asked to do maximize the objective function, we are getting x comma y 3, 4 as the correct. Only one point, only one unique point you are getting. But sometime you will get infinite number of solutions. For example, I will show you. I will show with one already done question. So if here the question is, I will give you the final points. Here our question is z is equal to 5x plus 2y. We have to maximize z. So you are getting so many constraints: 3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10, x greater than or equal to 0, y greater than or equal to 0. So the same procedure can be applied here, and finally you will get a graph like this. If you solve this question, you will get a graph like this. Here, this is 3x plus 5y equal to 15, and this line is 5x plus 2y equal to 10. The same thing you can follow here. So this is y equal to 0 and this is x is equal to 0. Here you are getting a feasible region like this. So this is our feasible region. Now you can, here our points are here you are getting three corner points. This is our corner point. 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 There are four corner points, and corner points. This is 0, 0, and this point is A. Okay. 5, 0. 0, 0. So A, B, C. This is O. This is A. This is B. This is C. The point here is 2, 0. The point, by calculating the intersecting point of these two lines, you are getting B as 20 by 19, 45 by 19, and the point C is 0, 3. 0, 3. So here, in this case, if you put these values, so our points are 0, 0, 0, 3, then 20 by 19 and 45 by 19. Another point is 2, 0. If you put, these are the corner points. If you put these values in our objective function, z is equal to 5x plus 2y. What you will get? Here you will get 0. 5 into 0, 2 into 0. Here you will be getting 5 into 0, 5 into 0 plus 3 into 5 into 0 plus 2 into 3. So we are getting 6. So this is our point O. This is C. This is B. This is A. If you put here 5 into 20 by 19 plus 2 into 45 by 19. So what you will be getting? 5 into 20, 100 plus 2 into 45, 90 by 19. So 190 divided by 19. So it can be calculated as 10. Similarly, for this case, when you are putting 2, 0, so you are getting 5 into 2 plus 2 into 0. So you are getting 10 plus 0. So 10. So you are getting at A and B in both points. At A you are getting value of Z is equal to 10, and at B also you are getting value of at 10. So in two corner points you are getting the same value. Then you can say that points we got is this one. This one. In this also you are getting value 10. Here also you are getting value 10. So the answer will be the segment between this A and B. The whatever be the points between A and B, all will satisfy this condition. Whenever whatever be the points you are taking between the points A and B, all the points here All the points in this particular segment will satisfy the z equal to 10 condition. So all points between A and B means there are infinite number of points. So we can call it as our solution is infinite number of solutions. Infinite number of solutions. So this idea you should recall. So we are going to stop our discussion regarding linear programming problems. Anyway, all the best for your upcoming examination. Thank you.